Hello guys, welcome to my YouTube channel. This is yet another project. So as you know, most of our households use solar panel as a source of power. A conventional way of charging a battery through the solar panels is usually connecting directly the cables from the solar directly to the battery, but this way is not a convenient way to supply the battery with the right voltage. So in one incident, you can have that the solar outputs a higher voltage than the battery, so that will in turn damage the battery cells. In another scenario, maybe it's at night, the battery is usually at maybe full capacity, 3/4 or half. So in such a situation, the power will be coming from the battery all the way to the solar cell, damaging the solar cells. To protect all these issues, we need to come up with a solution for this. So my solution was to build a solar charge controller, which will have couple of improvements. So it will solve the previous encountered problems with the charging direct through the solar panel. So let me highlight some of the solutions which I came up with. So first of all is to protect the battery against low voltage. The second is protect the battery against over voltage. The third is to protect the battery against cut-off circuit. The fourth one is to protect the battery against back current protection, and the other one is over discharge protection. So with this in mind, I'll come up with a circuit catering for all these challenges, and it will able to do its work automatically. So in my case, I'll be mostly using MOSFETs. Let me show you the circuit. So this is my circuit. On the right hand side, we have the battery and the solar connectors coming from the left hand side. So the positive terminal I've connected with a Zener diode, a 10 volt Zener diode, which will only conduct. It is reverse bias, so it will conduct when it reaches a voltage higher than 10 volt. So when it starts conduct, you will switch on the MOSFET, and current will be running through the drain or to the relay, which will switch on the on the relay. So the second condition is over voltage protection, which I've also used as Zener diode. So it is a 15 volt Zener diode. So when it goes above 15 volts, it will start conducting, and it will put this transistor in a saturation, which will let a negative voltage flow through the MOSFET, and it will switch off the MOSFET, and the MOSFET will switch off the relay. So the second condition is I've used the second relay. This second relay will deactivate the second relay whenever the battery has a full capacity of either 12 volts. It has a variable resistance for setting the value of your battery. So if it's a 12 volts, you just set it here. If it's a 6 volt, so whenever it reaches above that maximum voltage, it will switch off this relay. I think that's only the circuit. I'll be showing you how I connected my circuit. So this is my final gadget which I came up with. This is the first MOSFET, the second MOSFET, the third MOSFET. So the second MOSFET controls this relay, and the third MOSFET controls the second relay. The first MOSFET prevents the voltage from the battery from flowing back to the solar panels, and we have the Zener diode, this one controls over low voltage. It offers a low voltage protection. As the available resistor I was talking about, just set what your battery is capable of holding, the amount of voltage. So I'll be powering the gadget and trying to observe the data from the outer connector to the battery. So both relays are on. That means that the voltage coming from the solar panel has attained all the protection measures. So the first one was, it will only activate the first relay whenever the voltage is above 10 volts. So I'll measure the voltage on this connector and the other connector. Should be reading anything 12 volts or 11 volts. So it's 11.9, and the output for now it's 11.4. So adjusting the variable resistor will adjust the voltage going on the gate. So if I adjust it to its minimum, it will switch off this relay. So that's the project. Remember to like, share, and subscribe.